So question 1c follows on from question 1a. So you need to have done question 1a first. So let's just have a quick look back at question 1a. You can watch the video for it if you'd like a more in-depth explanation. So here's question 1a. So just have a maybe pause the video and have a wee read of the question and just make sure that you're really clear on how we got the answer for question 1a about good old Farmer Greg. If you're not clear about it, just watch the YouTube clip for that one. Okay, so I'm now assuming that you're clear on that question and that you know where the 0.4753 came from. So now back to the next page, so question C. Alright, so justify your choice of probability distribution. So we've got a verb straight away, a doing word, and that you've chosen part A of this question. Give the parameters, so there's another verb, another instruction, give the parameters of the distribution and explain, so another verb, explain how each of the requirements for the use of this distribution is met in this case. So explain how they're met. Okay. Discuss, so another verb, discuss which, if any, of the requirements for the distribution may not be met in practice. Okay, so let's just go through and make sure we're really clear on all those verbs, because that means that every one of those verbs, so just justify, every one of those verbs is going to have credit for it in the marking schedule. And so if you miss one of them, you can't possibly get full credit for the question. So always take your time. So justify, give the parameters, explain how each of the requirements is met, discuss which, if any, of the requirements may not be met in practice. Now, why have I highlighted the word practice, do you think? Well, the reason I have is because that word practice implies we're not just going to be talking about the theory of binomial distribution, we're going to be talking about the context. So that word practice is a big clue that we need to relate it back to the context if we want to get the marks here. Okay, so firstly, and as I just said, it is the binomial distribution. So let's firstly give the parameters. So the parameters for the binomial. So binomial distribution used to model the number of days out of 7 when calves were born. Parameter or parameters. Now you do need to memorize these, however, if you forget them, they're the things on your calculator that you type in along with the x value. So with the binomial, what are the two parameters? They are number of trials and the probability of success in each individual trial. So in this question, number of trials, it says out of a 7-day week, so that's our n value, n equals 7. Probability of success in each individual trial, well, the probability of calves being born on any given day during the season is constant at 0.625, so that's our p value. So we can write that in too. Here we go. Okay, so we're given the parameters, so we can tick that now. Alright, explain how each of the requirements for the use of this distribution is met. So with binomial distribution, there's an acronym, well it's not really an acronym, it's a checklist that you can use. And can you remember what that checklist is? 4 conditions needed to use the binomial distribution. And the way to remember it is International Fight Club 2. So the international, the in part, is for independent. The FI in fight is actually for fixed number of trials. The C in club is for constant probability P of success in each individual trial. And the 2 is to remind us that there are 2 possible outcomes for each trial, which is where the bi and binomial comes from, because it's the 2 possible outcomes in each trial. Now, if we rattle that off, we don't get any credit, because just memorizing those things doesn't show you understand anything about the distribution. So we need to spell out what we mean by each of those 4 things, and we need to relate it to the context. And that's the part in the question where it says, it talks about discuss which of any of the requirements of the distribution may not be met in practice. It's just a reminder that we have to talk about the context. Okay, so let's clear a bit. I'm going to clear off a bit of space here so I've got room to write. How well are the conditions for using binomial satisfied? So we need to start with that, and that's kind of our topic sentence. Okay, so I've made a wee bit of a table here. So I've got independent trials, fixed number of trials, constant P, two possible outcomes. And for each one I need to talk about the context, what it means in the context, and whether it's satisfied. I find that independent is often the hardest one to do, so start with the easiest one. So which one of these is probably the easiest one to answer straight away? Well, the fixed number of trials is pretty easy because we're told that there were 7 days. So farmer Greg observed these over 7 days. There we go. Okay, so I need to say 7 days. And satisfied? Yes. Fixed number of days. Alright. Constant P. Well, actually, probably the next easiest one to do is the last one, two possible outcomes. So what were the two possible outcomes that we cared about in question A? Two possible outcomes. So it was of calves being born, and the question was the probability of calves that calves are born. So success is that calves are born, and failure must be that they're not. So specifically, successful outcome is that at least one calf is born on that day. Failure would be no calves are born on that day. So let's write that down. So for each day, either calves are born, at least one, or no calves are born. So that's our two possible outcomes. And is that satisfied? Well, yes, of course it is. So yes, this condition is satisfied. All right, now let's move to the next one. Constant probability of success. So constant P. Now, first column, context. So in this context, P represents what? Let's go back to the question and have a look. And here it is. So it is this P of 0.625. And if we look at that, it says Farmer Greg's determined that the probability of calves being born in any given day during the season is a constant. So we're told that it's a constant, 0.625. So because we're told that, then that condition is also met. So let's write that down. So the context, P equals 0.625, which is the probability that calf births occur on each day, on a given day. Okay, so that's the context. Talked about calf births, and we also need to say whether it's met, and because we're told it's a constant probability, then that is also met. But we need to say that. So yes, told that this stays constant, so that's ticked as well. Okay, now last but not least, independent trials. So what does that mean in this context? First of all, we need to specify what counts as a trial. So what is a trial in this question? Well, a trial, that's every time something happens that could result in success or failure. So a trial is a given day. And the outcome that we care about is whether calves are born on that day or not. Okay, so independent trials, for those trials to be considered independent, it means that the result of one trial has no link or no effect on the result of another trial. So what does that mean in the context of this question? Well, pause the video and see if you can write it down. Okay, so it means that whether or not calves are born on one day has no effect on whether or not they're born on another day. So there's no link. So how can we write that simply? Well, how does this sound? That the occurrence of calf births on different days are independent. So it's the days that we're talking about, isn't it? Okay, so how confident are we that that is satisfied in this case? It's actually debatable, isn't it? What do you reckon? So let's go back and look at the question. Notice first sentence, Farmer Greg's determined the probability of blah blah on any given day during the season. So we're told that it's within a particular season. So what do you make of that? Well, that probably means, I mean, obviously calf births are going to vary from season to season. We know that. But if it's within a season, we can probably assume that what happens on one day is is not going to affect another day chosen at random. Now, there are some exceptions, and some students came up with some good answers here. Like, for example, if you know roughly how many are going to be born over the course of a season, which obviously is going to depend on the number of cows you've got and a whole bunch of other stuff, then if you know that heaps were born the night before or the day before, then and say you know that that most of the births that are likely to happen have occurred, most of the pregnant cows have given birth, then obviously you know that there's going to be not many births remaining. So there's some things like that. Don't write an essay here. How could we say that simply? How could we cover those things simply? Have a go. So this is what I had. I said, okay, so independent trials context, using a given day, the occurrence of calf births on different days are independent. Satisfied? Well, it depends. If most of the pregnant cows have given birth already, then less calf births are likely. So may not be independent in practice. And the question said in practice, didn't it? Okay, so let's have a look at our answer. Cool, so quick check. Have we given the parameters? Yep. Number of trials, 7 days. Probability of success in each trial is 0.625. So we've done that. Explained how each of the requirements is met or not by the distribution. Yeah, we've been through the 4 of them and we've related them all to the context and looked at whether they're satisfied. Then lastly, discuss which of any of the requirements may not be met, or which one were we a bit concerned about. Well, we thought that independence may be a dodgy assumption or a questionable assumption here in practice, and we talked about why. So we've done that. Let's have a look at the marking schedule and see what they said. Okay, so here we go. So you can see expected coverage, and we've got achieved merit excellence. So let's look down the column to question C. So you've got binomial distribution, check. Number of trials, check. Probability of success, check. Trials independent, assume. And it says, and we did talk about having to assume that. 2 possibilities, calves are born or not. Yep. Given the scenario and the problem, this is the obvious distribution to use. It's reasonable to assume that the births are independent. There are clearly only 2 possibilities and a fixed number of trials. We've covered the 4 things, haven't we? It says here then lastly, the only questionable issue is the constant probability. So that was different to what we had. It seems unlikely that the probability would remain the same from day to day during the season, given that the cows were probably all fertilised around the same time. I suppose that's kind of linked to what we said about independence, isn't it? So let's have a look across at what was required for each grade level. Okay, so for merit, it gives the conditions for distribution along with parameters, so we did that. Excellence, same thing, plus also gives a reasoned discussion, so a reasoned discussion similar to the one given concerning whether one or more of the conditions may not be met. Did we do that? Well, I suppose we did when we talked about independence. So this is an easy excellence if you know your 4 requirements and you remember to relate them back to the question. Remember, we don't have to write an essay, but we do need to talk about the context. That's calf births, whether or not they're born in a given day. And we do need to know our 4 conditions needed. So that's a good thing to memorise because it is an easy excellence. Know your distributions, folks. Thanks for listening.